Welcome to the Griffin Observatory, one of Los Angeles' most famous landmarks. But today we're not just looking at the stars, we're going underground into the story of Earth itself. Beneath the observatory lies millions of years of geologic histories, from oceans, volcanoes, rising mountains, earthquakes, and constant movements. All of these shape the Santa Monica Mountains, Griffin Park, and the land that the observatory sits on today. Join us as we explore the geology, the rocks, the process, and the significance of this incredible area. This is the geology of Griffin Observatory.
To understand Griffin Observatory, we have to step back. Way back, millions of years. The Santa Monica Mountains, where the observatory sits today, began forming about 16 million years ago. At that time, Southern California looked completely different because much of the region was underwater. Layers of mud, sand, and shale settled on the seafloor, and over millions of years, these materials were compressed into sedimentary rocks, such as sandstone, shale, and other marine deposits. Eventually, tectonic forces began reshaping the coastline. As the Pacific Plate moved northwest along the North American Plate, the crust here was squeezed, twisted, and stressed. The Malibu-Santa Monica Fault Zone became incredibly active, causing uplift that pushed the land upward and raised the early Santa Monica Mountains out of the ocean. Over time, new layers continued to form, including Cretaceous and Tertiary marine rocks, Oligocene and Miocene sedimentary formations, thick volcanic deposits that show ancient eruptions took place, and the Monterey Shale, a silica-rich rock created from ocean microorganisms. Layers are extremely complex and change quickly from place to place, proving how dramatically the environment changed over millions of years. The mountains didn't rise smoothly. They were folded, thrust upward, and shifted sideways, creating the rugged, jagged landscape that we see today. Now, the rocks around Griffin Observatory Park show cracks, bends, and tilted layers, evidence of the intense tectonic stress that shaped this region. Griffin Observatory sits right on top of this incredible geologic history.
The landscape around Griffin Observatory didn't form overnight. It was shaped over millions of years by major geologic processes. One of the most important was uplift and folding, where strong tectonic pressure pushed layers of rock upward, creating the high hills and steep ridges that surround Griffith Park today. This uplift is the reason the observatory sits at such a high point overlooking the Los Angeles Basin. Faulting also played a huge role because several major fault systems cut through the region, including the Hollywood Fault, the Santa Monica Fault Zone, and nearby faults such as the Puente Hills Fault. These faults fractured and shifted the rock layers, causing some parts of the land to rise while others sank. This movement created the tilted layers, cliffs, and rugged ridges that define the park's landscape. At the same time that the mountains were rising, the Los Angeles Basin was actually sinking. This created a deep, low area that filled with thousands of feet of sediment carried down from the surrounding mountains by rivers and erosion.